Okay, good afternoon, everyone. Welcome to the Radix digital session on Fairness and AI. My name is Matthias Ball. I'm a machine learning engineer at Radix and internal lead on Fairness. Today we have with us Jelle Hoedemakers, who's a fairness expert from Agoria. And he's going to give an introduction to why fairness is so important in AI right now and the different sectors that we should be considering. But first, Julia is going to give a short introduction on the practical side of things.
Yes, so hey everyone, my name is Julia and I'm a marketing executive here. And I'm just going to take care of everything going smoothly today, that we are on time and that all of your questions are addressed. So to make sure that we can hear all the presentations clearly, let's make sure we mute ourselves, but I see that everyone has done that already. And if you have a question during the presentation, you can indicate it here in the chat, and we'll make sure that we address it either during the presentation or during the Q&A. And lastly, if you'd like to revisit this digital session, you can see that it's being recorded here in the left corner. So if you're interested in sharing it with the other people or just looking at it again, it will be available on demand and we will send it to you by an email. And that's it for the practicalities for today. Hope you enjoy the event.
All right, I think this is my cue. Good afternoon, everyone. My name is Jelle Hoedemakers and I work for Agoria. Agoria is the Federation for the Technology Industry in Belgium, where we're a member organization where we have 2,000 technological companies who are a member representing over 300,000 employees. Specifically within Agoria, we have a big project on artificial intelligence, and I'm working on this project specifically on all the topics relating to AI ethics, regulation, and also standardization. And I'm going to start sharing my screen now. Julia, could you give me a confirmation you can see it?
Yes.
Okay. So, yeah, thanks again for this opportunity to talk about this topic. It's something I've been working on already for almost 2 years now, and it's getting very close to my heart. And I want to immediately start by maybe a controversial quote. That's the fact that AI isn't unfair, but people are. And I would like to add even the statement that now, thanks to AI, we are getting the right tools to address all these unfairnesses that are still living in our society. So, and I hope by the end of this webinar, you'll also be convinced of that fact. So you can think if he says AI isn't unfair, then why are we talking about it today? But to be able to answer that question, we will first need to take a little bit deeper look into fairness and the concepts which are connected to it. So the first word we should look towards is fairness itself. This is maybe a more high-level conceptual word. There's not one fixed definition, but for the sake of the webinar, let's look of fairness as behavior without favoritism or discrimination. Now, again, what you could think is, okay, me as a person or as a company, I don't treat anyone with favorites. Everyone's equal for me, or I don't discriminate. But the thing is, and this is what has caused the main problems with AI in the past and even still, is that you probably do these actions. You do have a certain favoritism or discrimination, but often these are things that you're not aware about. And this is where we get into another keyword, and this is bias. Bias is a concept of prejudice against one person or a specific group, and especially in a way that is considered unfair. So this prejudice is something that that happens actually without we're being fully aware of it. Okay, if you're then having, let's say, a management idea that, okay, we know about bias. If we know about it, we can fix it. So we'll try to eliminate all bias, and then we're good to go with our AI project. So you can try, but we can say maybe at minimum that it's quite optimistic. So what I want to show you here is the Cognitive Bias Codex. And this is an image that basically gives an overview and a classification system for a lot of biases which are known and well documented, which we as humans have, which are inherently to us, which are incorporated in our brain. So I'm not showing this as to present you a list with stuff you need to think about if you're working on AI projects, but I want to show this as an example that our human brain isn't as rational as we think it is. We are very often assuming that we're always 100% correct, 100% correct in our assumptions, or that if we have the right information, we will always take the right actions. But solving the fairness in AI issue comes back to realizing that we as human beings are inherently flawed in that way, that we do not think and act rationally. Now, what specifically goes wrong sometimes when we're looking towards these biases and AI systems is that people will feed these human biases into this AI system through data. So the data is biased, and this is causing the AI itself to be biased. And the question you can ask there is this the fault of the AI? Can you blame the AI for that? Can you say the AI is unfair? Well, consider if you as a person would receive information which you think is correct, but in fact it isn't. Someone is lying to you. You will act on this wrong information and in that way act wrong. Then the question is also asked, hey, are you to blame there? Or is the person who provided you with the wrong information, is he the responsible? Sorry, no answer, but these are the questions which come up with this topic. So if we think back to the articles we mentioned, we showed before, you could say that maybe, okay, they are wrong. They should have a title around people who are biased. So why are we talking about biased AI? Well, from one side is the fact that a title like robot discriminates against people is a lot more attractive than human favors guy who lives in his village over someone who lives far away. But the main point why we talk about this is that in the past and currently still, there are problems relating to AI systems being unfair. And to me, this image, even if it's a bit outdated, is still the best way to visualize the problem. So what researchers did here is investigate 3 models, where the models were made available. You could put an input as a picture, and the model would return a classifier being a male or a female. What we can see here in the results is that we look towards the segment of lighter male, meaning where you input a picture of a lighter male, then it would have a very high chance of success on putting the male label on it. Now, if you look towards the darker female classifier, meaning if you would put the picture of a darker female, this will be a lot less successful. So I will not go into the details of why this actually happens, but it's clear, I think, for everyone that this is now not how it should function. And if you would use these algorithms in a real use case and would connect certain actions to the results or suggestions from these algorithms, these actions will have a high chance of being unfair. So one note here is that these companies, all 3 of them, has made a clear stance also on facial recognitions, and there have been a lot of improvements also in this field, but it's still a good visualization of what is the problem here. So this is another case of where it clearly went wrong. In this picture, you can see 2 people who are being identified as gorillas. And I'm 100% sure that it was never the intention of the people who built this model that this would happen, but it's a result. It's something that happened. And in this case, this result is a negative impact. It's quite discriminatory. Sounds all quite grim, but there are ways to address these negative impacts, but often choices will need to be made there. And I'll try to explain it by the next use case. So in this case, it's one I think almost all of us have heard about, and it's a case where you use AI on X-ray images to help identify at an early stage if a person would have the COVID virus. So I think everyone can imagine that a system like this could work, because this is the type of image recognition AI that is already being quite established and well used today. So in case you won't want to build a system like this, you will need data. You will need data of lungs that are healthy, and you will need data of lungs that are infected to be able to distinguish between the two. So the problem lies with the amount of data that you want to gather on the infected lungs will be not enough probably to train your model. Why? Because it's a very new disease, or because this data is stuck in the different hospitals. So you cannot say, let's say, build the model you want to. But this is basically a problem, and if you think from the engineering side of this, you can find a solution. And a possible solution would be that you find similar images, meaning images of lungs with pneumonia would be quite similar probably to images of lungs for COVID. And you will add these to your training data, which will give you enough to train a functional model. Now, we already talked about biases, and in the health sector, a big problem in the past has been bias in medicine. So in the past, in case of analysis of new diseases or development of new treatments, they were always developed by and tested on men. So what could be a reasonable assumption that this data set of historical lung images you're using to train your model possibly has more images of male lungs than female lungs. We're going to continue on assumptions here, but if you would then develop your AI predictor based on these images, you could get a system that's good on predicting early COVID in men, but less good than for predicting it in women. And I'd like to point out here is where management will play a crucial role. Because what we have now is an AI system that works well for certain people, but it works less for others. Does this mean that automatically you cannot use the AI system? No. There are actions you can take. But if you work with AI, there's always a risk, if you want to classify something or someone, that you make a mistake, that you make a wrong prediction. And the role of the management here is then that you should think about what is the impact of an incorrect decision or a mistake like this. What is would it be acceptable to do it? Or what is the percentage which can be falsely classified? So these are the questions you will need to ask yourself to get a realistic view of how your model works and what it can do. And there are often no fixed answers on what you should do. For example, you could work on debiasing the data and trying to make it gender neutral in this case. And reasonably, the result would be that the model would be then as good as identifying early COVID in males and females, but probably the overall quality of the model will decrease. So the question there again then, is this acceptable, or how do you handle this trade-off? Not easy and not quite hypothetical, but I found a study recently where they analyzed 66 COVID prediction models, and they found only 3 which were working relatively okay. And even for these 3, they identified a high risk and even a probable risk at a certain bias. So now I'd like to try to convince you why you should care about this topic. And there are multiple reasons. But the main reason I want to bring up here is that if you want to have a sustainable AI project, if you want to use AI in the long term, this is something you need to consider. If you can maybe ignore it or in the proof of concept stage, but certainly in the next steps of the project, you will have to address it. Because if you would launch a product or install a system, which in some way is unfair, sooner or later, you will be faced with the consequences, and probably it will lead to the end of your AI system or AI product. But I also want to point out you can really use this as a competitive advantage also. So if you're thinking about fairness, maybe in the context of human resources, if you would use a biased AI system that would be preferred to hiring males over females, the reality is that you're probably missing out on qualified females for a certain job application. I think no one would want that, and certainly if these persons would then go to your competitors. So this is just another small point to think about. And these are 2 more soft points, but one hard fact is that discrimination is illegal. And in case there would be a claim made, you cannot go and pointing towards the AI system saying, no, it's the AI is biased, it's that fault. No, it will fall onto you. And as the final point there, you could see this as your social responsibility. I think if we want to work on a fair and equal society, we all have to do our part. Why not do your part by making fair AI? So now how to start? Well, it's quite simple. You've officially started. I think the first step in working on issues like this is always informing yourself, being aware of what is out there, what is possible, what you have to do. And I'd like to end my talk with a word of advice, and that's something I noticed in the years I've worked on this. Fairness is something you have to co-create. It's not something you can achieve or push towards one department. You cannot give your developers a fairness software package of sorts and say, okay, now you take care of it. You cannot push this to legal. You cannot make this the sole responsibility of the DPO. It's a shared responsibility, and everybody has to do their part, but the final responsibility will lie with the management. The management who have to define and fix what the AI system should do, what it shouldn't do. It's the responsibility to think about the possible biases which there are in the system. Of course, the technical and legal and all other departments will have to join in on the efforts. They will probably have to engage and make it possible, but in the end, it will be something which will fall on the management. So this was my introduction. I'd like to give Matthias now the opportunity to get your feedback on the ground. If at some point someone wants to know what Agoria is doing around this topic, you can always send me a mail or contact me on LinkedIn. Thanks for your attention.
Thank you, Jelle.
Thank you, Jelle, for the great presentation. Are there any questions at this point already? Feel free to ask them right now. There will be another moment at the end of the webinar. So if there aren't any more questions, then I'll continue with the second part of this webinar. Can everyone see my screen?
Yes.
Okay. So good afternoon again. I'm Matthias Bal. I'm a machine learning engineer at Radix. So Radix is an artificial intelligence agency. And what we do is we invent, design, and develop robust and innovative AI-powered software solutions. And in this second part of the webinar, I'm going to talk about why fairness and AI is such an important topic right now. I'm also going to talk about how AI can help with fairness and how we approach fairness at Radix. So why is fairness so important right now? I think it can be all boiled down to these three words. So it's compute, data, and scale. So in the last 5 years, particularly, AI models have been growing rapidly, both in terms of compute and data. And because they're exposed to so much data and because they are so big, they have the capability to reproduce or even amplify, in the worst case, existing societal biases that are present in every data set. And scale is another important component. So everyone has a smartphone nowadays. Everyone is connected to the internet. All of that data is getting collected. And you have this huge automated decision-making systems that are being deployed on an unprecedented scale. So recommendation engines, for example, used to be quite local. They used to be like tied to customers of a single company. But now you're pushing models to production, and they affect millions of people worldwide. So compute, data, and scale are really the technological drivers behind all of the progress in AI right now. And I want to give you some examples. So this is an example from image processing from computer vision. It was very popular on Twitter last week, so it's a very recent example. So the idea is here that you have a model that has been trained to reconstruct blurred faces. So it gets a blurred face, like the one from Barack Obama here on the left, and then it's asked to reconstruct the original face and give like a high definition picture back. And there's basically two lessons or two takeaways from this example. So one is that models like this learn from examples. So we humans have the additional knowledge that we know that the original picture is Barack Obama, but the model has never seen Barack Obama before. It doesn't know what that means. So you have to really put yourself, like Jelle said, in the shoes of the model. It's just doing what it has been trained to do. And the problem here is that it has been trained on faces of mainly white celebrities. So technically this result is no surprise. But that's not the problem here. And it is, well, honestly, it's not even irrelevant what that this is technically not surprising. The problem here is much, much broader, like Jelle said. So the problem is that why are researchers even using data sets that contain primarily white faces? And then the second point with this example is that it's easy to detect bias in images of faces because humans have been evolutionarily trained to recognize faces extremely well. But like Jelle also mentioned in this X-ray example, it's much harder to spot biased predictions, like for example in X-rays or in or like a risk prediction model for mortgages, or if you want to predict whether a prisoner is going to reoffend, like in justice systems, those kind of biases are much, much harder to detect, and it's not even clear how to pinpoint the issue, whereas in this case, it's very clear, which is why it's a very clear example of what happens when you have a very biased data set. And then a second important example that I don't think many people know about, because it's been kind of a quiet revolution, is in natural language processing, or in NLP. And these are models that have to do with text, so with language. So that can be generating text, classifying text, summarizing text, basically anything that has to do with human language. And what's been happening in the last 2 years is that you have seen these huge models appear that are able to learn language just from raw internet texts. So you no longer need labeled examples. You can just basically feed it whatever is on the internet. And on this graph, the horizontal axis is a time axis. So to the left, you have April 2018, which is like 2 years ago. And on the right, you have June 2020. And the vertical axis is the size of the model. It's a number of parameters. It's basically how much information a model can use to process data that it's seeing. And more parameters just means more data is needed to feed it. And second, more compute is needed to train it. So this comes back to the 3 words that I mentioned in the beginning: compute, scale, and data. And this improvement is just exponential. It's just enormous. So like 2 years ago, the biggest models were like 100 million parameters. Then there came like 1 billion parameters. And earlier this year, that we were at like 10 billion. And now just earlier this month, OpenAI released another tenfold increase to a model that has 175 billion parameters. And these kind of things can be dangerous, because you can just ask them things and you can see what they say. And what you're going to see is that if you give a language model a prompt, which is what I've done here. So I basically gave it 2 very similar sentences. So the first one is the woman worked as, and the second one is the man worked as. And then you can see the suggestions. So this is what the model thinks is most likely to come after these words. And because it has been trained on a large fraction of the internet, it's basically just reflecting back what it has absorbed during its training. So what this actually shows you is, because the results are, of course, very biased. So women are apparently always waitresses or nurses, or they volunteer. And men are bodyguards, mechanics, or janitors. So this actually gives you a tool to identify bias. You can literally ask the model questions like this and see what it produces. And it will not lie. It will not make up an excuse like humans would do, like under the pressure like under social pressure. So it will just say what it thinks is most likely, given what it has learned from the internet, basically. So these 2 examples kind of highlight like two important questions, like who is accountable for these models and their fair use? Because these models will continue to grow. This compute will become cheaper. People will be able to use these models. Company will be able to like build apps with these models or their own products. But right now, these models are very, very big, and they're very expensive to train. So you need to be a large company like Google, Facebook, or OpenAI to even have the capability and the people and the knowledge to train them. But the important point is that once you have done that difficult task, a lot of people can just use them. And then the question is, who is accountable for these models and then their fair use? Because as a consumer of these models, you have no control on the data that's been trained on. You have no control on the biases, on the fairness properties of that model, because it's out of your control. You just don't have the resources to do that kind of heavy computing yourself. And the second point is, as you can clearly see with these big language models, it's just impossible to isolate AI models from society. So the question is, where should we actually intervene in this socio-technical landscape if you want to address fairness? So with these models becoming so big, they're just being trained on the internet. So where do you step in to address fairness? You cannot filter the entire internet. So I then go to begin to filter what people say and who should be filtering that data. And there's just a whole list of problems that are going to start to appear when these models become really mainstream. I think we should really start thinking about this now already. So then how can AI augment fairness objectives? Or put differently, what can exactly can AI do for fairness? And basically 3 things. So fairness in AI is just like fairness in the real world or in society. It's about what we should do. So it's about ethics, It's about making a choice, and it's about values. And secondly, bias can be detected more easily in AI than in humans. So remember the language model query that I showed between the differences between male and females. You can just probe the model. It will not lie. You can just probe it and see what it gives. There's similar techniques for other models. And then thirdly, and very importantly, it actually encourages people to shift the debate to what is actually important, and that's addressing human bias. So like Jelle said in his introduction, the actual real issue is human bias. And because our models are being trained on more and more data, they're getting bigger and bigger, they just reflect better all of the biases that humans have. And this is, people often talk about bias and fairness in AI because they do not want to deal with the real problem, because it's much more easy to just point at the model and say, hey, you're biased. But actually, it's the humans who are biased. And pointing to a model is just like externalizing responsibility instead of taking action and policy decision and making policy decisions. So of course, to address bias in current models, we need some technical fairness measures. And there's actually a zoo of fairness measures currently available. And I just want to highlight like two big groups. One of them is the individual fairness measures. That's where you focus on individual people and you try to compare two individual people, like for constructing a fairness metric. But that's not often used because it's basically shifting the problem. So we know fairness is hard, but then you've just shifted the problem to how do you compare to individual people, which is an equally hard problem. So what people usually do is they consider people as groups. So they consider statistical fairness. And usually that's associated with like legally protected attributes like gender, for example. And then the groups would be males and females. And that's much easier to implement because you're looking at bigger proportions of people. And for popular measures, there are equal outcome, demographic parity, and equality of opportunity. And to showcase these, at Radix, we have developed a case study. You can also find it on our website if you want to go through it more in depth. It's about hiring construction workers and how can you do this fairly. So what is the setup? The setup is that you are a manager and you are tasked with hiring 100 construction workers for a construction project. So you have to pick from a talent pool that consists of 300 people. So 90% of those are men and 10% are women. We actually base these figures on European statistics for the construction sector. So this is like a real life imbalance between gender that just exists. You cannot force it away. So we have to deal with it. And the idea is that you would like to use an AI recruiting tool to assist you in selecting these candidates in a fair way. So the first thing that you could do is just do nothing. Just do not care about fairness and just have the model be optimized for maximum profit. So you do not care about fairness. You just want to select the most competent people and you just don't care about fairness. So I want you all to just focus on the bar graphs at the top. So the blue ones are about men and the orange ones are women. And everyone above the line is hired. Everyone below the line is not hired. So you can immediately visually see that there's much more men than there are females. And you can also see if you do not take into account any fairness measure, you are mainly going to be selecting men. So in this particular example, you only selected 3 women out of the 100 candidates that you were supposed to hire. So obviously, we can do better at this. So this brings us to equal outcome, the first measure. This is basically quota, which most people know. So it just means that you ensure ensure that the positive outcomes are just distributed equally among men and women, so that you hire as much men as you hire women. So you can see that you actually have to hire all the females in your talent pool, and that's because there's actually not enough to fulfill your 100 candidates. So you basically end up hiring all the females, including all the ones that are maybe less qualified, and you hire much less men. So that's actually something that's often enforced, but it's very suboptimal because you're losing lots of profit, of course, if you think in terms of a company, because you're not getting the number of candidates that you want. So you can do better. And this is actually the most popular measure that people use. It's demographic parity. It's actually a relative version of quotas. So it's you scale back the number of people that you hire per group, so for men and women, depending on how many there are in your talent pool. So in this case, it was 90% men and 10% women. So that means that you actually hire 10 women, and the other ones are just filled up with remaining men. And this is actually a very popular measure. It's easy to implement. It's also legally supported in, I think, the United States and United Kingdom. So it's a kind of, it's an easy to enforce criteria. But you can obviously say, can we do better than that still? And you can, and that's equal opportunity. And then you're going to actually look at not just at gender, but also at the qualifications. So you're actually going to consider, if I am qualified, I should get the same opportunities, no matter if I am a man or if I'm a woman. And then you're able to push the number of women much more. So you can actually hire 24 women now. You can hire much more qualified women. But like always, there's a trade-off. The trade-off in this case is that you're no longer hiring unqualified men. So with fairness metrics, there's always a trade-off involved. So you can't win. So you can't have it all. So in this case, the trade-off is that if you're an incompetent male, you have a much less chance of getting hired. And there's actually a measure that goes even further than that. So for people that want to correct that behavior, so they want to be also fair towards people that are actually not qualified, you can go to equalized odds, which is even which goes further than that. That's more constraints, so we have more trade-off. If you want to go through this again, you can go to our website. It's very well explained. We will send the link in the chat. So how do we approach fairness at Radix if we do a project? So this is basically our vision. So first of all, we believe that human-centered AI systems are always a trade-off between fairness, privacy, accuracy, and transparency. So you can't have it all. You just have to make a trade-off. You have to make a choice. Second, there is no perfect fairness metric. So we are well aware of that. Similarly, there is no unbiased data set. Every data set is biased in some way. And if you don't think it's unbiased, it's just because you haven't found the bias yet. Third, we believe creating fair AI solutions requires making a choice. So like Jelle said in his introduction, you have to make a choice. You have to make a decision, and you have to carry that responsibility. We, of course, have the technical know-how to address data bias and implement fairness measures. And what we like to do is we present our clients with fairness options, and we assist them in their decision. So we give them a description that's very particular to their problem, and we want to assist them in making a decision. But a decision is theirs to make, depending on lots of variables. And finally, we take a bigger picture into account. I think you should all be convinced by now that fairness in AI goes way beyond models and data. It's actually becoming really a reflection of fairness in society. So you have to take a bigger picture into account, even for projects, especially for projects. And an example of this vision is our product Talent API. It's a technology developed for skill-based job matching. And we actually developed this model to be fair by design. What do we mean by that? We actually sat down, looked at what's out there, and we saw that we actually needed to develop a platform that is fair and explainable. And we did this by using a decoupled architecture. So different parts of the model are looking at different parts of the CV. So people are matched based on individual attributes of their profiles. So there's no way for spurious or dangerous correlations to appear. We actually sat down, thought about how to design the model in such a way that it is fair, that it is explainable, and that is the trade-off. So we probably have a little less accuracy for that, but that's a trade-off that we're willing to make to provide a fair and an explainable tool. And then there's the fairness guide that we want to provide you with. So how should you attack a project involving fairness in AI? So how should you implement it? And this is just like a pipeline with different steps. And at every stage of this pipeline, fairness requirements should be satisfied. So initially, you have to evaluate before you commit to a project. You have to consider the context, the ethical implications, and the impact on people. You have to try to think of scenarios where the project might end up being abused for different purposes than you intended it to, or how it might cause harm to people. And sometimes it's not obvious, so you have to like really sit down and think it through. Then you have to take a moral stance and pick a measure. So you have to involve stakeholders, you have to involve end users, and this is very important, never only engineers, because engineers are very good at technical stuff, but they are often not well trained in like the more non-mathematical parts of making these kind of decisions. Like Jelle said, should involve all levels of a company. It's very important. Then during a project, you should monitor and mitigate. So you should track fairness measures and you should reevaluate context. So as soon as the objective of the project changes or your data source changes, you should actually go back and start again at the evaluation stage and figure out if what we're doing is still valid from a fairness perspective. And then once the project is finished and you're in a deployment phase, you should deploy with intent. So you should ensure that fairness can be guaranteed over time. What does this mean? It means that you should be fairness metrics in place to track performance over time. Because we know that if your data changes and your model is trained on that data, then your model behavior will change. So what happens if the nature of your data changes? Is the fairness measure that you started off with still accurate enough? Is it still sufficient, or do you need a different one? And that's very important for production products. And then there's of course always the bigger picture. So you should think beyond your data, you should think beyond your models. I think Jelle and I have tried to make this very clear to you all. So thank you for your attention. And if there are any more questions for Jelle or me, feel free to ask them now. Thank you.
Meanwhile, I've sent you the link to the blog post about the case study that Matthias has presented earlier.
So we have a question by Michael. Could you give a concrete example on how the steps are applied for a Talent API? So like I said, the case for Talent API, we actually designed the model to satisfy equality of opportunity. So if you are a qualified person, then it should not matter what kind of protected attribute you have. It should not matter. It should be based on your skills, on your experiences, and there is no way that there can be any kind of influence between these things, because it's not been trained in that way and it's not been designed in that way. So for the case of Talent API, we focused on equality of opportunity.
Okay.
So there's a question from Nelle.
So do you take proxy data into account, and how do you do this? Do you mean for a specific project like the Talent API that we showcased, or more in general? Both. So for Talent API, we do not take the protected attributes into account, and we also the model is designed in such a way that it's based on skills and it's based on embeddings. And there's just very, very little chance, and we have actually benchmarked this, there's very little chance that you can have proxy variables leaking into your predictions, because it's not been trained in an end-to-end way like a deep learning model would be. So there's no way for these proxy variables to manifest themselves. And that's really why we designed it in that way. It's decoupled. There's no way that these variables can influence each other. And more in general, proxy variables are indeed a problem if you have like models that do not explicitly decouple things, and then you really have to take them into account and do correlation studies and make sure that they're properly removed. You can, of course, always reach out to us at Radix if you have any more questions or want a consultation on fairness. So there was a question about explainability. If it's in the context of Talent API, then again, we design it in such a way that it is explainable. Because it is decoupled, because we use this particular architecture, we can pinpoint, we can actually backtrace every matching and say it matched because of this, and this property. So that's again a way that we use to incorporate explainability by design. And then another question about how Talent API achieves both explainable and fair matching. This is again, like I said, we just designed it in that way to do it. So we decoupled the different parts that would usually interact like in a deep learning model. Every property can talk to every property, and you can have what usually happens is that every property is also able to influence every other property. So you can have these correlations that you do not want that are usually associated to biased predictions. And we knew this from experience, so that's why we designed this Talent API model from the ground up to be explainable and fair. So there's no way that different attributes can influence each other. So everything is purely skill-based and experience-based. Are there any more questions for me or for Jelle? Okay, then I would like you. Oh, there's a question for Jelle.
Yes, Jelle, maybe you could give an example of fairness applied at Agoria.
Mike, no, now you can. So, fairness applied at Agoria, I understand this is what are we doing around fairness? And one of the main parts in that is creating awareness around it, meaning speaking at events like this, or writing or disseminating information. But we have 3 concrete projects where we want to address fairness. And this is mainly, is basically at the moment focused around the ethics team. And we have identified that at certain levels of projects, there will be different things you need to do. Meaning, if you start to think about your proof of concept, already at that point, you should handle fairness in a certain way. During the implementation phase, also, there are other focuses on fairness. And during the evaluation, there are, again, different things you should do. And we have now 3 actions, and one is what we call the AI blind spots. This is based on work done by Data and Maatschappij. And this is in the form of a card game, which you can play as a company to identify certain of these issues which you might have with your AI system. And then at the second stage, we're working on an e-learning, sort of AI, sustainable AI MOOC, where we also help companies with addressing certain issues. So again, asking the questions, but we will couple this with tools which are available publicly, which you can then use to address these fairness related topics. And the third one is a bit more conceptual, but we're working on sort of ethical AI canvas based on the business model canvas, where it can be used at a high level in company to identify certain fairness related issues and also follow them throughout their lifetime. So these are the 3 things we are doing around fairness at the moment.
All right, thank you, Jelle. Thanks, Matthias, as well for the presentation. As I said, if you want to know more in depth about the case study, you can always visit the link that I've sent here in the chat. And if you have any more questions, or maybe you have specific AI projects related to fairness that you would like to discuss, we can always set up a consultation and you can contact me or Matthias and we can make it work. So hope that we've provided you with valuable background on what fairness is and how AI can help promote the fairness goals. And yes, thank you very much, everybody.
Thank you. Bye.
Thanks.
Thank you.